to HEC RAS Bootcamp Session 4. Today, I thought we would go over some more on bridges because that is the hardest part of HEC RAS modeling. We were scheduled to go over Manning's in values and standard output tables, which I can easily show you in the last session we do next time. But if you go ahead and open up the HEC RAS model that for today's training session that I sent out. One thing I wanted to note that I know there's a lot that in like the last session, there's a lot of steps, and I don't want you to be thinking like you have to memorize every single thing I'm doing, but just understand the big picture of, hey, we're taking a bridge, we're taking this information from the plans, we're using basic geometry to try to relate that to what is going to go into HEC RAS, and then we're putting it in there. I know y'all can I have to wrestle with the basic algebra and stuff on each one because everyone's a little bit different, and where I'm pulling the source data might be a little bit different each time as well. So just understand what it is that we are doing and why we're doing it, and not so much every single equation I'm using and stuff like that. So do y'all have the HEC RAS in the spreadsheet open right now yet?
Not yet.
I will go ahead and share my screen as I navigate to the Excel file. And let me know when y'all have everything open. You got it? But you, Delise, you got it, Jonathan?
No, I'm watching. I'm
watching?
Sorry, I'm watching. I gotta give someone PW access, but I'm watching because it messes me up when I try to do it and watch you at the same time anyway. I always miss steps, so it's better that I just watch you.
No problem. Jonathan and Tamara got it, so we'll go ahead. So in HEC RAS, if you got the file open, go ahead and hit the running man. And we're going to open up a different plan. We're going to open up the proposed plan here. And let's change out the, you guys. Sorry, let me.
I was gonna say, I think.
Yeah, open up
okay,
the
now it makes
proposed
sense.
JMT.
Okay.
Yeah, the proposed JMT. I had it the wrong model open. And I meant to do something that I didn't do before sending it off. So let's open your bridge culvert data and just delete every bridge that's in the model. So go to this bridge/culvert and say options, delete.
So how'd you get to that bridge and
Where
geometric
it kinda-
geometry data thing?
Yes, so slow down. All right. So this is your geometric data. This button here, the third one from the left. Click on here, and then from there, hit your bridge and culvert. And then,
quick question. On your study flow
Yeah.
file, you have the corridor effective existing?
yes.
Okay.
Yeah, where we would eventually put the proposed in, but this one's still being
Okay.
worked on.
Okay.
So, go ahead and delete these two bridges out, or these three bridges actually. Say options, delete bridge culvert. Say yes. And then on the next one, options, delete. Yes. Options, delete. Yes. Okay. And then you should have no bridges in your file. Let me know when you're at that point. You got it tomorrow. How about you, Jonathan? What else following along?
So there should be nothing.
Yes. No bridges. Correct.
Okay.
Okay, so if I were to look at our DGN file right now, we've got, this is our proposed. This is a little different from the one we were doing our last session on. So I know we have a bridge here. This is our, this is north. So this is actually the westbound frontage road. So we have some culverts here, not a bridge, sorry. And then we have other culverts for the main lanes. And then we have another one for the eastbound frontage road that takes a bend here and goes like this. So in HEC RAS, that would correspond to between these two stations and then between, I should slow down because I know it doesn't. So between these two stations for the westbound culverts and then between these two for the main lanes. And then between basically this area making a bend for the eastbound. So let's start just by entering the bridges we have in the model. So this would be just a way of starting to do the work for these bridges. So let's start with this westbound frontage road bridge up top. For that one, let's go to Excel here. In your Excel file, find the tab that says westbound frontage road proposed. Did you find that yet tomorrow, Jonathan?
Got it.
Got it? Okay. And if you remember from last time, the important links that we need are between, or the distance from the upstream cross-section to the bridge base, and then the overall width of the roadway or culvert. So I'm just going to do a little bit of measurements to show you here. That would be this distance here. It's about 1 foot, and then that would be for your length of the culvert. It would be from here to here, and it's about 48 feet. So that information, it's been entered a little bit different, 49.5 a foot, but that's very close. And I've done that for all of these three culverts that we're going to be adding. The other thing is where does it fall? So it falls between River Station and the model, between get my cross sections, somewhere between 1371 and 1318. So if we need to give it a name that falls between that, so it doesn't have to be, you don't have to calculate a specific number, it just needs to fall between that. So let's call it 1350 as you see here. And now in HEC RAS, let's go ahead and add a bridge there. And let's go to open your bridge culvert data and then say options, add a bridge or culvert. Y'all got that yet?
Yeah.
Okay. And then let's enter the station as 1350. And say okay. So if I click on my geometric data now, I don't see anything yet because it doesn't know how big that bridge is or anything like that. So we're not going to enter all the information for this yet. We will for the eastbound frontage road. That's what we'll spend more time on. But let's go ahead and enter this deck roadway information so you can see what it does. So I think we said, what was it, half a foot here for the distance?
Yes.
And 49, is that what's in the spreadsheet?
Yep.
So if we enter that in there, did everyone follow how I got to this? Deck roadway editor. Did you get that tomorrow, Jonathan? Good. Okay, so we're gonna enter those, say okay. And we don't really have any information about the culvert entered in yet, but you'll see that it shows up in the geometric data. And this should start looking similar to what you have in your geometry, in your DGN file, if you entered it correctly. So the next bridge will be between these two. So that's going to be between, this is going to be for the main lanes bridge. That's going to be between station 1290 and 1141. Again, it doesn't matter what number I put between there, as long as it's between, HEC RAS will know where to put it. In this case, I try to use what the effective model had, if possible, or the corrected effective. So they'll be the same name. I'm going to call this one 1225. So let's go ahead back to the bridge culvert and go options. Oh, before we do that, let's go ahead and call this one the westbound frontage road culverts and hit apply data because we always give bridge structures names in HEC RAS. It's just good practice. Now go to options, add a bridge culvert, and let's add this one at station 1225. And this will be the main lanes. And if I go to the deck roadway, this information would be measured from this upstream cross section to this deck here, 16 feet. I've already entered that in the spreadsheet. Maybe I have. Let me see. The total width is 135 feet. Actually, tell you what, I don't have my proposed roadway shapes turned on, which I should. So measuring from here to here, that's where you get the 9.99, 10 feet. Total width of it is about 132. I have 135, so let's enter this information. 10 and 135. So if we go to the deck roadway, 10, 135. Now that one pops in. Our next one is these culverts on the eastbound frontage road, and they're a little goofy looking, so it's always fun to see how it's gonna come in the model. I drew this section before putting the culverts in, and it's actually a little bit in front of it, but it's not worth recutting the section, so I just pretended that it's half a foot in front of it because we're going to be entering the roadway deck data anyway over this. So what I did for that one, this is the eastbound frontage road proposed. Go to the distances here, it's got 1 and then 207 because this one bends, so that was the length along the center line from here to here to here, 207 feet.
Enter that in as a 1075, I guess.
Yes, this one goes in at 1075. So I'm gonna go to bridge culvert, I'm gonna go options, add 1075. Then to get it to show up, I'm gonna add this 1 and what did I say, 207? Hit OK. And so we start to see something that is looking a little bit like what's going on in the plain view geometry. So that's good. Yeah, it kind of HEC RAS takes the links you give it and interpolates that between the total length between the sections and decides how big to draw the structure. So that I wanted to show you all that and just make sure you understood about adding culverts and the upstream distance and the width concept. And then now I want to work more on this eastbound frontage road bridge. So in your spreadsheet, go to the eastbound frontage road proposed. And this project, we're in schematic and it's proposed. So what we have to work off of is basically the schematic roll plots right now. You know, they're not too far along in their bridge design or their and the bridge structure design, so they don't have bridge layouts, but what is shown, and I guess this isn't a bridge anyway from the one we're working on, but we do have the roadway profiles that they show on the culvert layouts. So this is looking at this eastbound frontage road bridge, which is actually a little bit of a hairy situation because if we think about it, we've got on the upstream side, we've got a cross section, but we're always thinking in terms of looking downstream. Downstream is to the left on this one, going down into the left. So we've got the eastbound frontage road on the upstream side, and on the downstream side, we have this other road, which is Wood Springs Road. So we've got this downstream section here. And so we've got this roadway profile, and this is for the downstream end. And we want to find a way to relate this to what's in HEC RAS. So what I want to go over, and this is where don't get lost in too much detail, but try to get the basics of what we're doing. So we have in HEC RAS, wherever our cross-section line starts, looking downstream. So it starts, this is my left side looking downstream. If I go to the HEC RAS data at that cross-section, which is going to be the downstream one on here, it generally starts at station 0 at the far left end. So this is my 0 here. And then you measure it along the cross section. And so what I've done on this one, and I've kind of gone ahead of this so we could power through it, is we know at station 17 plus 0, 0. So if I look at this station, 17 plus 0, 0, this is 1591. This is 16. Okay, no, this is 16, so that would be 17. 5, so that's 17 plus 0, 0 as far as the roadway stationing is concerned. But as far as HEC RAS is concerned, I need to measure this length here. So I go from here, that's 0, to where the cross section bends, and then to approximately here. And I get about 617, 618 feet. So I have this relationship that, and sometimes it's not perfectly straight, sometimes it is. At 17 plus 0, 0, it's station, I said, HEC RAS station 616.7. That's what I measured the first time, so we'll just go with that. And then what I'm concerned with in here is mainly what the roadway profile does from here through here. So in that case, it is pretty straight as far as I'm concerned. So I'm just going to create a direct relationship between stationing and the centerline stationing and HEC RAS stationing. So to do that, it would be the adjustment would be minus 616.7 minus 17 plus 0, 0. And y'all know the plus 0, 0, you can just ignore the plus sign as far as math is concerned. So minus 1700. So the adjustment is negative 1083, or in other words, centerline station minus 1083.5 equals your RAS station. So what I've done is we've looked at our roadway PGL data here, and then we've adjusted a HEC RAS station here. And then the other thing we have to consider is the PGL may not be the highest point that we really want to get. So if I look at and right now I didn't see a cross section for this road, but I did see that it was super elevated at 5% based on this call out here. And this total width was 40 feet wide. So I can make an adjustment to the highest point. Half of 40 feet total width would be 20. And then at 5% slope. So I can make another adjustment for the elevation. But you have to do that kind of stuff with your roadway profile to get what you want for the roadway deck. So this is the adjusted elevation. So I did those steps so we could kind of speed through this process. But if you take your adjusted station here, this is on the downstream end, and copy the values into here, downstream station. Then do the same with the adjusted elevations for the roadway deck. Copy those. And then paste the values. Any questions on that? Did y'all follow? Were you able to get to that point, Jonathan? Good. Okay, so that is the name of the game, is translating what's in your profile to what your RAS stationing is and getting that to show up. And so when we do that, we should start to see, that's why I do these plots. we should start to see, this is downstream end, something that looks in general like, remember RAS, we're looking downstream, which is the same way. This one is kind of situated the same way, which makes it easier. So we see that, you know, we should have something starting kind of dipping down like this. I think in the Excel file, this is approximately where the culvert is, so it should start to come back up around the culvert, and we see that. Another thing I went ahead and did for this is I calculated the center stations for us so we could go a little quicker. So the downstream center line station is 750. So if we go ahead and we have 5 culverts, so let's make 750 here. Let's change that to the middle one. And then let's make these other ones an equation, and they're actually 10-foot culverts. So let's put 12.5 feet between the center lines. Let's drag that. 750, so 750, 750. Well, man. So that will give downstream stationings of should we try to do it to that one? I'll be able to drag it. So then we start to see I think there's a little lag. Oh, you need these elevations. I think there's a little lag in the spreadsheet, but we see the profile looking pretty good, pretty similar to what is actually going on here. Let's test some elevations, 429.26 in the bar park. We've got 430.26 because there's an adjustment for the cross slope. So that's looking pretty good to me. Now for the upstream side, we are against this eastbound frontage road. So for that, I have the roll plot for the eastbound frontage road that I can look at, and that is right here. And we're somewhere in this area. So I'm going to take all this data, which we've already done to speed things up, all this data in this vicinity. Now, why I wanted to show this one is it gets a little tricky sometimes, and this kind of shows that because our stationing is going, which way is the stationing going on this one? If you notice, it's going increasing this way, but your HEC RAS station, you're looking downstream, so it's going to be increasing in the opposite direction. So we have to put on our algebra hats a little bit and know that. Let's look at the DGN. So in the DGN, we've got, why I turn the shape off? It gets in the way. The end of that is at approximately 2623 plus some change. I think I measured 67 earlier. So that is approximately 2623.67, but it's going backwards. it's going the opposite direction of RAS. So that means as the station gets smaller, your RAS station is going to get bigger. So your equation becomes 23, 26, 23, 67 minus your centerline station equals your RAS station. So y'all follow that? Solving for the unknown. You don't. So we know that. Say that again.
Not really.
Okay, we can go a little slower. This part, just the concept of it, I have to think through it every time because it's just like, oh, okay, it's going the wrong way. It makes me think twice as hard. But that's why I wanted to show this example, because so you wouldn't get stumped if this happens. So you got your roadway increasing stationing this way.
Right from left to right.
Yeah. But thinking RAS, we're always looking downstream. So at this upstream cross section, this is my station 0. So like over here, I'm at station 67 or something. So as I decrease in this station, I'm increasing in my RAS station. So algebraically at 26, 23 plus 0, your RAS station is 0. But then as it gets smaller, your RAS station gets bigger. So to write that in an equation, it's this 26, 26, 2, 3, 6, 7 minus your centerline station. So that is this station here, 26, 23 plus 67. That's this one minus whatever station you're really at. So that gets the length. So if I'm at 2620, then that's 367 because that's 367 if it because I measured that as 367 theoretically. Does that make sense? I think you're nodding your head. So that is what happens here. And then I wrote down all these stations and all these different points from the profile that I could get. Sometimes you'll actually have the profile. The one thing that I note is like some of these where it's a vertical curve, they give a station and I just try to estimate what that little higher elevation is. And then on this one, we do have a typical, and we can see that our PGL is here. And then the highest point in the roadway deck is going to be 16 feet over at a 2% cross slope. So I can make that adjustment for the roadway by adding elevation plus 2% times 16, 2% cross slope, 12-foot lane plus 4-foot shoulder. So I just put this information in there so it's there. And then if we go ahead and take this data and your adjusted RAS station, copy it up here. Let's go ahead and we'll try to wrap up here soon, but I want to get it in the model. So this is upstream. So let's paste it over this. And then let's take our adjustments for the roadway deck and paste it over the high chord. Okay, now for your upstream culvert center lines, let's go ahead and if you look up here, I already wrote down. So the upstream center bridge is about 797. So that would be measuring. I can do that. So you'll make sure y'all understand that would be measuring from my upstream section to the middle of the bridge or the middle of the culverts, which is about right here. So 659. Actually, I did the wrong one. this one. This is my upstream section. And to right there would be about $7.99. So I just wrote that down. I put that at $7.97. Let's go ahead and copy these equations from the other side, and then it'll adjust based on the $7.97. I'll change my colors back, so that would be, so that should, and then the same. So this, let's just adjust this equation wise to be minus, we'll assume 12.5 between them. Then that should be able to be dragged up. So there. So my Excel should, this one looks a little goofy, but remember it's exaggerated and it's looking at the roadway profile backwards. So it's looking at this roadway profile from this side. We should be at around 450 elevation, somewhere around there. It should get down to around 435, somewhere around there. So we see that here, left side, 450-ish and 435-ish. And we've got those in there. So let's go into HEC RAS so we can see this. And this won't take too long, but let's go ahead and go to your bridge culvert on eastbound frontage road 1. Let's go to down to this one, or actually 1075. So you should have something like this. And now we're going to enter that deck information. So if we go to our deck roadway editor, and let's take all of this stuff. Y'all following? Copied and pasted it. Should go right in and you should see something like this. Did you get that?
Okay.
And then did y'all get that? Too fast or
Got it.
you got it? Okay. So now almost there. We're gonna have to, next thing, let's go to your culvert. What I would do if you're like me and you got all this stuff in the way, try to drag some of it to another screen so you can see what you're doing on the spreadsheet. So culvert editor, I want to be able to see those center line stations is the main thing. And let's change it to a concrete box culvert. Up here, change the shape to box. Flared wing walls is fine. That's fine. That's about what I'm doing. Let's make these 10x5s. And let me just give you all the flow line information because I have that. Where 421.49 on the upstream and 420.45 on the downstream. So let's go ahead and 421.49 upstream. say 420. 420.45 on the downstream. I don't know how this is going to turn out. I haven't done this for this one, but hopefully this works. So we've got 5 barrels that we're going to model, and it wants to know the upstream station and the downstream station for each one of them. So let's just go through and call them barrel 1. 772 is your upstream station off of here, station here, and then 7, and I guess really I would enter these into the spreadsheet, that and then the top of the culvert by adding the rise to it as my elevations if I was storing the spreadsheet, but that's just for documentation purposes. We can power through this one without worrying about that. And then on the downstream, it's 712.5. Then the next one is 784.5 and 737.5, 735, 737.5, 797, 750. The last one, or 2 more, 809.5, 762.5. And then finally, 822 and 775. And then let's give these just barrel 1, barrel 2, barrel 3, barrel 4, barrel 5. The distance, I'm going to put the same stuff as we did for the roadway. So that's 1,207 because we basically use the culvert geometry to measure that. Entrance loss, most of the time you won't go wrong with 0.5. Want to look and verify, you can go to this and see what type of head wall you're using. And if you scroll down here and try to pick the best one for an entrance loss coefficient. We've got square cut into pipe. That's basically what happens if you got a head wall, square cut into pipe. You could sometimes, it's 0.5. And then your exit loss is you won't go wrong with 1. It's just not an exact science. I'm going to use 0 for the blocked in. If I was doing an existing model, even if there was obstructions, I generally wouldn't model it because we want to do a comparison as if the existing was in good condition. So sometimes we will put an in at the direction of the client, or just like if they say, or if it makes sense to assume some sedimentation, sometimes we'll assume that. So if you've got all that entered in there, this is not needed, I don't believe. And so if you've got all that entered in, hopefully it's going to turn out looking somewhat close to what we're expecting. Yeah. So you've got the main channel and we're making, this is, oh, one thing's not expected. Hold on. This I messed up somewhere. You got 1, 2, 3, 4, 5. One of them maths got off, so it's 772, 712, 737, 784, 822. That is on my downstream end, and it's at 707.5, where's that?
That's not in there. It's barrel one, and barrel one says 712.5.
Yeah, 712. So that should be, I think that did some bad math. I didn't have the equation there. Minus 12.5. Yeah, this is to the center, and that's the edge that I'm clicking on. So that should have been about 725 for that station. So we do that. Should look more normal. So you see the existing section here, but we are modifying the geometry, so it's not alarming that, and actually if I think about it, so it should make sense. So the creek looking downstream on the upstream end, you got the culverts and then the creek. And so we look at our section and we got the culverts here. So I have the existing topo, it's hard to see. But the existing culverts are over here, so that makes sense that the creek's actually over there. And on the downstream side, you got more the creek and then the culverts, it looks like, possibly. Yeah, downstream, you've got starting the creek and then the rest of the culverts. So this will get into the part where we did the modification of the internal sections like we did before. We'll have to do that on this one. But that's, I wanted to show you all that about relating how we typically have to relate something that's like this on the roadway profile into something that is going into your HEC RAS geometry like that. So that was the main thing. I could extend this out further. I doubt the water gets up this high, so it's probably not gonna matter too much. But if I elected to, like I could extend this out, keep going with the roadway profile as long as I did with the section. But you see this all the time in models because we only collect so much data, and it's not really wrong unless you have water coming out this far. In this case, we might, so I might need to extend this out. So that goes 2,000 feet. Actually, I thought I went a little further with that stuff. That's 2,000 feet. Did I? Let me check my. Oh, that's the upstream end, downstream end. Yeah, the downstream end did not go out as far because we look at the DGN. Remember, that was the one for this road. So I basically got this data, and this cross section kind of turns and goes along here. So I would almost need to like marry the rest of these elevations, or I'd probably just take an estimate of these elevations out here to extend that further out. Does that all make sense conceptually though? What all we did? It gets hairy trying to relate this stuff, and it takes time to like take a cross section and figure out, okay, how am I gonna translate this into HEC RAS? It's possible, like if it's a windy road, that you could have different equations at different points and stuff like that, but you just want to be thinking, I got to get this information that represents my roadway into HEC RAS somehow. So, any questions? Were y'all able to get the culverts in? Cool. We don't have any questions. I hope that helped, and we'll save this and upload it to YouTube. We'll talk to y'all later. Have a good one.
Thank you.
How do I stop
you,
recording,
sir.
Delise? Oh, she hung up.